Hello and welcome you in the course of probability and statistics. Now today we should learn about say one of the important topic in probability, say permutation, and I am your instructor, say Hardik Joshi. So let's move on the topic, say permutation. Now first of all we have to just learn what is permutation. So suppose that say there are say n distinct object is given and we are interested to pick up or drawn r objects out of say n objects. Then permutation leads out of these n objects there are how many different possibility to pick up r objects. Now that things is permutations. So since there are say n different object as we have to discuss, so we are just discuss one by one. So what is the probability or possibility to selecting the first objects? So as we know that there are total n objects, so as per your conveniency either you have to pick up the first object, second objects, third objects, yeah, in general n objects. So for selecting the first objects you have a n possibility. So when the first object is selected, then we have to discuss about what is the possibility of selecting the second objects. So one object is already selected and now we have to discuss the possibility of selecting the second object. So there are one possibility is removed. So for selecting the second objects, right now we have n minus 1 possibility. So when two objects is selected and we have to discuss about the probability of selecting the third object. So again two option is removed. So probability of selecting the third object is n minus 2. And here we are interested to selecting say r objects out of nth object. So the probability of selecting the rth object is n minus r plus 1. So finally we have to combine the output of all these in one single line and we have to identify what are the all over possibility of selecting the rth objects among the nth objects. So that thing is known as a permutations. And now if we have to talk about in mathematical terms, so what is the mathematical aspect formulation of the permutations? So is denoted by this NPR, where P stand for the permutation, the suffix n stand for the total number of objects, where the suffix r stand for out of n objects we are interested to pick up or drawn rth objects. So mathematical formulation of NPR is a corresponding to permutations, where the first term represents that is n. N represents the possibility or probability of drawing the first object. The second term that is n minus 1 represents the probability of drawing the second object. The probability of drawing the third object is n minus 2 and we are interested to draw r objects. So finally the probability of drawing the rth objects is n minus r plus 1. And if you have to see carefully this expression, then there are total say r term, so sometimes it is also known as r factor. Now see here in particular when we have to consider say total number of objects and the total number of objects which we are interested to draw both are same, that is r is equal to n. So when r is equal to n, what is the formulation of the permutations? So NPR is replaced by say NPN because r is replaced by n. So the probability of drawing the first object is as it is n, probability of drawing the second object is n minus 1. In the same direction the probability of drawing the rth object as we have to see is n minus r plus 1. But here our aim is we have to not draw r object, we have to draw the nth object. So the same expectation, the same formulation is extend. So n minus r plus 1 and so on, say 3, 2 and 1. So if you have to see the carefully, so these are the nothing, these are the formula of factorial, that is n factorial, and we have to assign say is a equation 1 because later we have to use this formulation. So we can write the permutation in terms of factorial. Say NPR is equal to n factorial upon n minus r factorial and say equation 2. So remember equation 2 is nothing, just equation 2 is obtained from the equation 1, by multiplying and divide by say n minus r factorial. So denominator is clearly seen n minus r factorial, numerator n minus r factorial is multiplied, so it becomes the n factorial. Here we have to discuss one of the particular case. So when r is equal to n, that is total number of objects, and the objects which we are drawn, if both are same, then equation 1 as well as equation 2 both are same, that is both are agree. And now this thing is possible if and only if we have to assume, or we have to say that 0 factorial is equal to 1. So from again this first and second expression we have to say that 0 factorial is 1, and remember these are one of the assumption, yeah, definition. If we cannot assume 0 factorial is equal to 1, then the whole procedure, that is permutations, becomes the wrong. So these are the definition. Now for better understanding, let's see the example. In the first example, first example tells that the number of different arrangement or permutation consists of 3 letters, each that can be formed from the 7 letter, say A, B, C, D and so on G. So the question says that there are total 7 letter, say A, B, C, D up to G, and we are interested to draw 3 letters out of this 7 letter. So if we have to combine the question 1, that is first example, with the concept, yeah, definition of permutation, then you have to understand the total number of objects, that is here total there are 7 letters. So we have to correlate, that is n is equal to 7. What is small r? Small r is stand for, now out of this total object we are drawn how many objects. So here we are interested to draw 3 letter. We have to select a 3 letter, so r is equal to 3. So by plugging the value of n and r in the formula of permutation, we have to get say 73. So by using the mathematical concept, say it's become say 7 into 6 into 5, and by solving that we have to get say 210. So the first example tells that there are 7 letter, we have to draw 3 letter, so there are total 210 possibility. Let's see the second example. Say second example tells that in how many way can 5 differently color marble be arranged in a row. So second question tells that there are total say 5 different color marble, and we are drawn or we have to arrange in a one particular row. Then there are how many possibility. So let's deal with the solutions. So suppose we must have arranged 5 marbles in 5 positions. So first of all we have to assign say 5 blanks, and now one by one we have to fill up all these blanks for better understanding of the topics. So let's see how we can fill up each and every blank. So for selecting the first position, that is selecting the first marble out of 5 marbles, there are say 5 way of filling the first position, because in first position we are interested or we are select the first marble, yeah, we have to select the second marble, select the third marble as well as fifth marble. So for fill up the first position, now there are say 5 positions. So as you have to see, the first position is filled up by 5. Now when the first position is filled up, then we are interested to fill up the second positions, and now to fill up this second positions there are say 4 possibility. Because why 1 is reduced? Because 1 marble is already left. Suppose we have to selected in first position say 4th marble, so the 4th marble is removed. So for possibility or position of the second marble there are 4 possibility. So second position is fill up by say 4. So up to this stage we have to obtain say 5, 4. Now next we have to remain or fill up the remaining positions. Then there are say 3 way for fill up the third positions, and the same way say there are 2 way for fill up the fourth position, and finally we have to say that there are say only 1 way to fill up the fifth, that is last procedure. So by combining all this output, we have to say that there are total say 5 into 4 into 3 into 2 into 1 possibility. So we have to conclude that say number of arrangement of 5 marbles in a row is nothing but is just given by the multiplication of is all this number. that is 5 into 4 into 3 into 2 into 1. Yeah, you have to say that 5 factorial, that is 120. So there are total 120 possibility for selecting or arrange 5 marbles in a row. Now let's see one next example. So example 3, say in how many way can 10 people be seated on a bench if only 4 seats are available? So see the question carefully. There are total 10 people and we are interested to seated these all 10 people, but the restriction is there are only 4 seats. So let's move on the solution. Say the first seat can be filled up in any of the 10 ways. So for selecting the first people, right now we have 10 possibility. Now, and when this has been done, so for selecting the second people, there are one possibility is removed, that is 10 minus 1, that is 9 way. In the same direction, say there are 8 possibility for selecting the third position and 7 possibility for selecting the last position, that is fourth position. So we have to summarize that. Say there are total 7 into 8 into 9 into 10, that is 5040 possibility for arranging 10 people in a 4 seat. Let's see one more example. Say how many 4 digit number can be formed with 10 digits, say 0, 1, 2, 3 up to 9 if repetition are allowed, repetition are not allowed. So let's start the first one. The first digit definitely is not 0, because if you have to write down 0 as a first digit, then it is not a 4 digit number. So for first position or first digit there are say 9 possibility. So for second, third and fourth digit can be any out of that 10. So we have to say that there are say 9 into 10 into 10 into 10, that is 9000 number can be formed. Let's see the second option. The first digit can be again not 0, as we have to discuss. If we have to plug in 0 as a first digit, then it is not a 4 digit number. So for first digit there are 9 possibilities. The second digit can be out of any of the 9. Now the third digit can be one of 8. Any but those which cannot use the previous one, because in second option the repetition is not allowed. Similarly the four digits can be any of 7. So finally we have to say that there are say 9 into 9 into 8 into 7, that is 4536 possibility is occur. So thank you.